Hey everybody. We're here to do a small video. Relatively. Wanted to show you a couple things. Now, I'm going to do a couple of small demos here that we've probably all seen before, but it's relevant to what I'm going to show in the end. We'll start with this little neodymium magnet. One side's got a red stripe, the other side's got a blue stripe. This here is our pole indicator. The red stripe is south, which makes the blue stripe north. But as you can see, our pole indicator works. Our neodymium demonstrated that. We're going to show what an electromagnet does with this pole indicator. So what we have here is a ferrite core with 120 wraps of 28 gauge copper, which is the same right here, which is sitting inside this open core Vortex coil. Now I'm going to turn the power on from this power supply, which is 20 volts 20 amp or 24 volts 20 amps, but I'm going to use like 7 volts, barely anything at all, just to demonstrate the pole indicator and how it's going to show up. All right, 3, 2, 1. So that side's the north side, which would make this side the south. No power, doesn't show anything. Okay, as we can see. Alright. So we now have our core in here. So when we turn the power on to our Vortex coil, and we have voltage show up in this meter, which this pickup coil here, the ferrite core with 120 wraps, goes to a full wave bridge rectifier and a 100 picofarad capacitor. And then to this meter to show what's in that capacitor. Okay, so we're going to turn our circuit on, show you the voltage, and then we're going to take our pole indicator and show you the pole on this ferrite. Alright, we're pulsing at 1000 hertz, 20 volts per pulse square wave at 10% duty cycle. 3, 2, 1. Okay, so we have 87 volts. We're going to turn on our pole indicator. Nothing. Nothing at all. Interesting. I don't know if the camera could pick it up, but I'm getting breakout at 12 volts. There's 90 volts in the pickup coil, but no pole. Interesting. Okay, so we're going to shut off our circuit. And we've seen the magnet and the pole indicator. So let's take the magnet and the pole indicator and show the side of the magnet. Oh, it does pick up part of it. Not very well, but it picks it up. Okay. So we're going to change our experiment just a little bit. We're going to pull this ferrite core out of here. We're going to change our frequency on our frequency generator to 7.83 hertz. That's an interesting number. I'm sure a lot of you know what that number is. That number is the resonant frequency of Earth. I believe it's the resonant frequency. Don't quote me on that. Nikola Tesla used to use 7.83 hertz for multiple reasons. It was his kind of go-to when it came to resonating with the ground, his Wardenclyffe tower. At least that's the theory. Alright, so what I'm going to show you is I'm going to take this magnet and I'm going to put it standing up in the middle, and I'm going to show you spin, but not just spin. If everything goes right, if it flips the right way, I'm going to show you orbital spin and polarization. Alright, so we're turning it on in 3, 2, 1. Okay. So it flipped to the blue line down. So it's polarized to the point where it ain't going to even move. But if it flips the opposite direction, watch what happens. 3, 2, 1. Orbital flow. that not crazy? I'm not picking up. I have to get close for the magnet to pick it up, or for the pole indicator to pick it up. Watch this. Okay, now of course, it's got a mind of its own. Don't try this at home, folks. And if I take the magnet out, and I'll turn the power on, as you can see, nothing. I don't pick up a pole. If I had a piece of iron, say, maybe like this, let's see if that picks up a pole. Nothing. Interesting. Alright everybody, that concludes our demonstration for today. I hope you all have a great day.